So today we'll talk about AC and DC, alternating current and direct current. They are the two types of electric currents we use. So what is an electric current? Well, electric current is the flow of charge or the movement of electrons. So first let us talk about DC or direct current. So here I have a wire, and this part over here is connected to the negative terminal of the battery, and this part over here is connected to the positive terminal of the battery. And the electrons in the negative terminal will be attracted to the positive terminal, since negative attracts positive. So now the electrons are going to go across the wire to the positive terminal. As we saw, the electrons went in one direction, in this case, right. This is why we call it direct current, going in one direction. Now let us talk about AC or alternating current. So here I have a wire and a magnet. Since the south pole is positive, then the electrons are negative, they will be attracted to the south pole, so they will move towards it. So they bend to the right. But now, what we're going to do is we're going to rotate the magnet, and since north is negative, the electrons are going to move away from it. So if we rotate the magnet, the electrons will alternate directions. They will go right and then left. So if we rotate the magnet, they will alternate directions. They go right, then they go left, then they go right, then they go left, and they'll keep on doing this cycle of going right and left and alternating directions. And this is why we call it alternating current. So now you might be thinking, if the electrons are just alternating directions, then how can they move across the transmission line? This is a major misconception. The electrons don't need to travel across the transmission line, or they don't need to have any displacement. Rather, the electrons must be in motion. This motion is what we call electrical energy. This energy is going to be transferred across between the electrons and flow across the transmission line, not the electrons. So it's this energy that's going to be flowing across, not the electrons. Now let us compare AC and DC. So one advantage of DC over AC is that DC is more efficient than AC. This means that during transmission over long distances, AC has more power loss than DC, meaning that it is less energy efficient than DC. Also, DC appliances such as DC motors and LEDs are much more efficient than AC appliances like AC motors and incandescent light bulbs. However, AC motors are cheaper to maintain and last longer than DC motors. One major reason why AC was the preferred energy source was because it had been cheaper to transmit AC over long distances than DC. This is mainly because the AC transformer is much cheaper than the DC transformer. And also until recently, it has been easier to transform AC voltage than DC voltage. One advantage of DC over AC is that solar panels and emerging renewable energy source creates DC. However, we have to also keep in mind that wind energy, hydropower, and other energy sources all create AC power. Another advantage of DC over AC is that you can't store AC current, unlike DC, which you can store in batteries. This means that you have to convert AC to DC if you want to store it. And the AC-DC conversion process has a lot of power leakage. As we have seen, DC is more efficient than AC, right? Because it has been more cost-effective to transmit AC over long distances, AC has been the preferred current until now, and our electric grid infrastructure is built for that. But more recently, with new technologies such as ultra-high voltage DC transformers, it is becoming inexpensive to transmit DC also over long distances. And so going forward in the future, DC could become the preferred way to transmit power over long distances, given its other advantages. We are already seeing that in some of the new grids being built in countries such as China and India. Thank you for watching my video, and as always, watch my video on batteries over here and my video on magnets over here. Subscribe to Kids Days Kids and stay tuned. Bye!